Okay, next. We have the discriminant to determine how many answers to the equation we'll have and what kind. Okay, the discriminant is the part of the quadratic formula that's under the square root. Okay. So if it's greater than 0, so positive, and it's a perfect square, you get two real roots. Sorry, two real rational roots. If it's greater than 0, but it's not a perfect square, you get two real irrational roots.
What does it say, and what?
And what kind of roots? Okay, so you get two real irrational roots. Okay, so if it's a perfect square, the square root goes away, so it's rational. If it's not a perfect square, you still have a square root in your answer, so it's irrational. That's the difference between those two. Okay, if what's underneath the square root equals 0, you just get one real root. That was like our first example where it equaled, or second example where it equaled 0 and we just got one answer. Now if it's less than 0, that's a negative number, right? That's where you get two imaginary, well not imaginary, sorry, complex roots. And complex numbers are in the imaginary number system, and we are not dealing with those just yet. Okay. What these look like. Your solutions happen where you cross the x-axis. So if you get 2, you're crossing the x-axis twice. If you get 1, you're just touching the x-axis in one point. And if you've got none, like it's a negative number, you're not touching the x-axis at all. Okay. So if this happens, you just write no real solutions. Okay. Okay. So when we use the discriminant to describe the number and type of roots, we do just this part, b squared minus 4ac. So I do negative 11 squared minus 4 times 7 times 5. So that's 121 minus 35 times 4, so that's, I don't know what that is. 140. So this is negative 19, right? So I have two complex roots. Now, if this was a problem I was trying to work out, I would not get an answer. I would write no real solutions. A, B, and C still. Okay. So here, there's no A, so A is 1, B is 22, and C is 121. So I do B squared minus 4 times A times C. So that's 484 minus 484, so that's 0. If this equals 0, what I have is one real root based off of the chart that's on the previous slide. Here I have 8 squared minus 4 times negative 5 times negative 1. So I get 64 minus 20, which is 44. Okay, 44 is It's not a perfect square. So because that's not a perfect square, but it is positive, I'm going to get two irrational roots. Okay, so the point of this is that when you're working the quadratic formula and you get that answer that's under the square root, as soon as you see that number that's under the square root, you're going to know how many answers you're going to have and what kind they are. If you have a perfect square under the square root, you're going to have two regular number answers, two rational answers. If you have a negative number under there, you can just stop. You have no real solution. If you have a 0 under there, you're only going to get one answer. If you have a number under there that's not a perfect square, you're going to know that you're going to get two answers with a square root in them. That's just what this is for. This is just so you can quickly look at it as you're working the problem and know how many answers you need. Okay, it's good. Okay, so we're solving quadratic equations. That's what this is all about. When can you use each method? Well, graphing sometimes, but only if you don't need an exact answer. Factoring only works if it's factorable. Square root property only works when you have a perfect square here. Completing the square will always work. However, completing the square is best when you have a situation like this where there's nothing in front of the x squared, because otherwise you have to divide by that and you get ugly fractions usually. Quadratic formula always works. And there's no limitation to it. Like quadratic formula works when you've got fractions, when you've got decimals, when you've got funky numbers. It will always work. Okay?